Welcome back to the ThermoDiet podcast. Today we've got a very special episode for you guys. We are joined by Kyle Mamounis. How you doing today, Kyle?
Good. How are you?
I'm good. So Kyle has a PhD in Nutritional Sciences from Rutgers, also a fellow New Jersian, and a BS in Biology from Rowan. So it's going to be really excited to pick your brain and hear how everything works in your head and all that stuff. So how'd you get introduced to Ray Peat?
I think it was through Danny Roddy stuff he was doing back around 2011. I was very active on a raw, it was called Raw Paleo, but kind of like a raw carnivore forum. Mm-hmm. Rawpaleo.com or rawpaleoforum.com, something like that. And sometimes people would just post stuff of other diets like, hey, look what this person's saying. And it was when Danny was talking about Ray Peat's like high calorie, like Danny went through a phase. I don't even think I've talked to him about this, but where he was just eating a ton of calories. I think it was the Matt Stone thing. He was being influenced by Matt Stone and the Eat for Heat. Okay. Yeah. So the idea is like, if you have a health problem, maybe you just need to give your body like excess energy for a while. So he was doing that and everybody was kind of making fun of it on this forum because, you know, people that are into more of like the paleo or carnivore stuff, it's, you know, more about fasting and stuff like that. So I had heard the name because, you know, the name came up and I was like, well, that seems wacky. And then but it was just kind of interesting. And then I went to the first Ancestral Health Symposium in 2011. And I met Danny because he was friends with this guy, Lex Rooker, who I met through this forum. And he invited me to stay at his place in LA where that symposium was happening. So then, like, you know, I met Danny in real life. So I followed him on Facebook and I just started like reading Ray Peat's like articles on his old website with the ice cream cone. And then that's the fall of 2011 that I started my PhD. And so I started taking all these courses and started looking into research and stuff. And a lot of the things I was learning, I was taught like pretty traditional nutritional biochemistry, which started to like explode a lot of the carnivore and like low carb sort of stuff that I had been learning for the previous maybe 5 years. It started to kind of crumble. And then Ray's stuff started making a lot more sense in the face of like doing a PhD. Mm-hmm. So that was basically it. So yeah.
Cool. So you have like a very interesting perspective because you've changed diets, like and I don't mean to like be in a negative way, but it's very interesting because like I feel like a lot of people go from one end of the spectrum, like you kind of like put your foot in a little bit everywhere. So like and you've talked a lot about how like diets tend to be kind of like a religious thing where it's like carnivore, keto, like that is the way. Like how did you transition from one to the another? Like what caused these transitions?
It was like the same thing as a religious transition. I remember feeling like pretty emotionally disturbed, like having essentially a crisis of faith after being like presented with some information that just kind of hits a certain way or some seed that's planted in your head and you start to question this thing that is like, you know, when you're into these kinds of diets, it's a very important part of your life. And yeah, it's bad. It's like dark. You go through kind of this nihilistic period and then you're kind of like getting like falling out of a boat. And then there's like a life raft and that's like your next thing that you believe in with the diet thing. So it's like, oh no, like I'm not going to live forever and never get sick at all. Just eating like a raw vegan diet. Like that's not true. Oh no. Like, and then you're drowning. And then you see like the carnivore thing or like the Agenus Vonderplanets or whatever it is. And you grab onto that. So yeah, I did that, you know, 3 or 4 times. And it was actually, I think that the Ray's ideas, I mean, there was definitely some like maybe excessive belief in some of the things he was saying that I was engaging in. But I think because it's not really like a systematic diet in the same way. So I think that combined with just doing my own research and sort of, I guess, outgrowing, like having to believe in some other expert and just a few things at the same time, Like I don't have that feeling anymore about diets, and I don't think I ever will. But yeah, for a while, it's like a dark religious transition.
I was doing intermittent fasting for a while, like pretty crazy, probably doing like 20-hour fast while doing a lot of activity. Other than that, I kind of hopped straight into Ray from Christopher Walker. I don't know if you're familiar with him. He's the owner of Room Zoo. He was like on like Anabolic Men back in the day. And I don't know, I definitely felt like more of a religious asset to Ray. Like when people like were questioning what I thought was right in diet, like at first you're like, oh no, you're wrong. It has to be this way. But I feel like the more you learn, the more you kind of like take ideas and able to parse them out and like say, give your belief and give rationality as to why you believe certain things versus just saying like black and white, it has to be this way.
Yeah. Yeah. I mean, people definitely do the religious thing with Ray's stuff, but it's not the same way because like it's not like cut out this macronutrient or, don't eat meat or don't eat plants or whatever.
If you were going to give advice to someone like to not be religious about it, what would you say? Like try to be more, I guess, rational.
That's tough because I think the way I got out of it was like kind of as a consequence of doing, a PhD in nutritional science. So that's not really accessible to almost anybody else.
But you can read for sure and like try and educate yourself, and maybe not to the same extent.
Right. I mean, you have to, this is for anything. This is for any kind of belief. If you want to, change the meta way that you think about something, you have to develop your own perspective. And that's just a process. Like you can't really do, if you just start reading like philosophy or whatever a subject is, and you don't have any kind of foundation, then you can't really have a perspective. So unfortunately, I mean, I guess, like I'm trying to think if somebody was young and they were introduced to dietary ideas, how could they be presented with that and take something from it without just like, falling into like, this is the thing. That's very difficult. Maybe if they had like a family tradition of like nutritional traditions, like maybe an immigrant family that still has a connection to like some type of cultural roots. But for Americans, I think, it's
tough.
Almost impossible.
Yeah.
Definitely watch and or listen to my YouTube videos.
Your YouTube channel is great. I've been listening to the Kyle and Friends. I really like your podcast with Pedro, analyzing a lot of the science of the science. And I would like to dive into that. But yeah, I'm reading Stephen King's book right now on writing. And he talks a lot about that. It's like when you first start writing, you're going to be copying someone else's style of writing, like whoever you enjoy. And then it's like 2, maybe 3, like couple books in, you start to develop your own voice. I think that's kind of what you were alluding to.
Definitely. Yeah. I would say, with like the arts and things like that, it's the same because being able to write something like literature is just having a perspective. Like you have to have a perspective to not just copy something else. And it's the same with having thoughts about like a scientific idea.
Can you give the listeners like a background on all the diets you've been in? I just want to ask you, like, did you ever feel bad on any diet, or was it always just out of pure scientific, let's say, exploration that you decided to like, this was the end of that diet and switching to the other one?
I've never switched diets because of like a health crisis, but I had, I guess, what I would later identify as negative symptoms on each diet, like particular problems. So when I was raw vegan, and I can't even fully blame this on the diet because when I started doing raw vegan, I didn't know. I mean, I knew what calories were in the sense like a high school student knows what calories are, but like I didn't know the caloric values. And also I was reading books like the David Wolf, like the Raw Food Manifesto, or what was his first book?
I have not.
Is it just called Raw Food?
I think it's something like that. I've not really looked into the veganism side of things. It's probably something I should do a little bit more digging into.
Yeah. So I was reading things that were sort of just saying calories don't matter. Like none of this stuff matters. Like what you need is the life force energy of like raw plants in your body and stuff like that. So one, I didn't know anything except like what maybe I had picked up from like just being a teenager in America and going through high school. Cause like it was like mid college that I first got obsessed with all this stuff. Well, I guess I started with vegetarian because that was like, I started hanging out with these like political people. and they were all like, well, half of them were like vegetarian activists, you know? So I started being presented with like, you know, cruelty, animal raising cruelty literature. And then of course the health claims. Mm-hmm. And I just couldn't ignore it. You know, it's hard for me to ignore anything in the realm of ideas. And there wasn't really, at this time, there wasn't an opposing carnivore force in the culture, like in the, like you say, year 2003 or something. Paleo was like probably just something in the head of like Loren Cordain over in California, and not, you know, on the internet. And the internet wasn't really the internet. So, yeah. So but having said that, so with raw vegan, I mean, I was totally under eating. And definitely under eating protein, but just everything, calories in general. I lost a ton of weight. I had a decent physique before that. Like I'd lifted weights through a couple of years of high school. And then as I was going into college, basically lost like everything. Like I'm like last time I weighed myself, I was actually below 175, which I was surprised at, but I've been like as heavy as 180, and like maybe 170 would be low for me right now. And I'm like fairly lean, maybe like middle teens body fat percentage. I was like below 140. So that was the problem with that, is basically I couldn't like put on or even maintain weight. And then when I did carnivore, I gained a little bit of weight. I was probably eating more calories. I was definitely eating more protein, obviously. And carnivore, and then also kind of like an endogenous von der Planets thing with raw milk. The problem with that is I think the low carb aspect of it and the fasting, like I used to do this thing my first semester in graduate school. I think it was Tuesdays off. I didn't have to teach. I didn't have any classes. So I just stayed home because I lived like an hour away. So I commuted an hour every day to graduate school. Gotcha. And my MMA gym had morning classes. So I'd go to the morning classes. So I would do like an hour of Muay Thai and an hour of Brazilian Jiu-Jitsu fasted Tuesday morning every week. And I would have a migraine. Like no matter how much carnivore, like how much meat and suet or whatever the fat I was eating, I tried to consume after that like intense stress that just like sucked every probably bit of glycogen out of my muscles and liver and just dug deep. I would just feel a migraine coming, and it would stay with me. It would like form during that Tuesday, no matter what I did, and be with me all day, and sometimes maybe even into Wednesday morning. But most of the time it would go away at night. So basically like I started, and then when I added carbs back to my diet, I was able to like not basically like, you know, it's kind of like when you have a hangover and you're dehydrated and you get like sort of a migraine like that. I mean, for me, like if I let that happen, so that was my main problem, is like working out and just stressing my body. I could like feel the effects when I was on a very low carb diet. And I still couldn't gain that much weight. Actually, I think I got up to like 165. But yeah, there was no like, oh, I'm having this serious problem. It was mostly a scientific decision that I would change these diets and this like, crisis of faith. And then in retrospect, I would go back and be like, oh, you know what? Like maybe it wasn't normal to have a migraine every week, because I would do this like fasted 2-hour, pretty intense workout.
Yeah.
And nothing could stop it.
Yeah, it's interesting. But in those spheres, it's like, I don't know, you're probably just not working hard enough or something. Like it's typically, that's one of the paradigms I feel like of the non-repeat diets. It's like you have to suffer to be optimal, because our ancestors like suffered in some sense, like the ketosis, like the intermittent fasting. Not that it's inherently suffering, but it's like we don't have this plethora of resources available.
Yeah, if I was better ketogenically adapted, then that might not have happened.
Yeah, you weren't fasting long enough, and your marathon training was not there. So, yeah,
right.
I was doing intermittent. So I said that before. I was doing intermittent fasting. So I was like going to the gym, landscaping for 8 hours, and then I would come home, and obviously I was like I lost a lot of weight at the time. I was trying to cut for summer though, so it like looked good. And then I would go home, eat a ton of food, and go to jiu-jitsu, eat some ice cream, and then do the same thing over again. I didn't really have any health issues, but I was like looking back, I was very reactive at things. Like I snapped a lot more easily than then. I've mellowed out a little bit now, having some carbs back in me. What are you currently researching at in Sweden?
Yeah. So I joined this lab about 6 months ago, and yeah, this is what we were talking about right before you hit record. So yeah, I sort of took this position like sight unseen. Like there were some labs I interviewed for that I sort of understood the project better. This one I kind of didn't understand the project, and I was like, they're just going to give me something to do, and I just sort of had faith that like, okay, I'll just be in the lab and then I'll just come up with my own ideas because that'll just happen naturally. Mm-hmm. And so it did. So I was like reading a lot, and I'd never worked with fish. So I wasn't even working with animals in Florida. I'd worked with mice at Rutgers, a little bit of rats, mostly mice. And so, yeah, so I had to like learn how to work with fish and like breed these fish, and all this kind of molecular biology I've never done before, like cloning genes into these fish and just all this stuff with the fish. And, and so the focus of the lab, the main topic is, regeneration of beta cells, like mostly in the context of type 1 diabetes, where you would lose beta cell mass, like nearly 100%. Mm-hmm. And there's also some other stuff like getting intestinal cells to produce more incretins to stimulate insulin and stuff. But it's all kind of around insulin recovery in the context of diabetes, mostly type 1, mostly beta cell regeneration. And everybody in the lab kind of has a different way they're going about it. Yeah. So I thought about it for a really long time. And then I started, because, one of the Ray Peat, like, I was actually thinking of making this meme, like Ray Peat, like esoteric Ray Peat starter kit, and just have like a bunch of books and like a red light and like a carrot or like something like, and one of the books would definitely be Robert Becker's, The Body Electric. Have you heard of that one?
I have not. It sounds interesting though.
Yeah. Ray used to talk about it. He's this surgeon. He was, I think a surgeon that worked at a VA hospital, and he was, I guess, an MD PhD. So he was doing surgery as a doctor and then also research. And he started studying animals that can regenerate limbs fully versus animals that can't. So like some frogs can regenerate fully, salamanders, different types of things. Planaria flatworms are like the best. Like you can just cut them into 8 pieces and you'll just get like 8 good worms.
That's great.
Like that's just how they reproduce.
Okay.
It's just be cut. So he found out, and there was a little bit of literature about this, but the way that their nervous systems and their electric currents work differently. So he started doing experiments like trying to block the way that the electrical system was working, like in a frog that could regenerate a limb, and he was able to make it no longer able to regenerate a limb. So be more like an animal, like, a mouse or something that would have like only partial regeneration if you cut off as an adult, one of its feet or something. And then he was able to induce, bring that back. And he did a couple experiments on humans, to help them like mend, a fracture that wouldn't, what's it called when they won't come back together. And like usually the limb has to be amputated. Like if you break your femur and it won't, like fully broken through, and it won't
really, I didn't
come back. Like you can't just have a split bone.
Yeah, that makes sense. I didn't know that was an issue, but that's it.
Yeah, it's rare, but like, yeah, sometimes there's like healing issues, especially, with older people. So, so people have been picking up on that recently. And this guy, Michael Levin at Tufts, who's, I guess, at the forefront. I don't know, maybe there's somebody else that's also famous for this, but this bioelectricity stuff, he works mostly with frogs and tadpoles. So I started reading his stuff, and then I reached out to him and started emailing, and there's not a ton of people doing zebrafish. Mostly they're working with amphibians. And there's basically nobody doing pancreas or beta cell regeneration using bioelectric physiological targets in zebrafish. So I was like, all right, I'll do that. So I have a bunch of experiments like sort of planned out. Like I buy these chemical libraries that you can get from labs of different drugs. So some labs actually make like chemical libraries that are a bunch of drugs that target ion channels and things like that. So just getting fish eggs, like mating two fish, collecting a bunch of eggs, treating them, like just growing them up, being exposed to certain chemicals and seeing if it makes their beta cells grow more or less naturally, or killing all their beta cells with this chemical, and then seeing how much they regenerate, or if they regenerate more in the presence of this chemical, doing like some molecular stuff, like giving them a gene that's with insulin promoter that would like be like an ion channel or something to change the voltage potential of their beta cells, things like that.
So is the
kind of it's tough to explain outside when you're not in research.
Yeah, completely. So basically, like, the goal, at least in part, is to kind of knock their beta cells out of use, to kill the beta cells, and to see if you can use certain biological impedance to influence them to at least partially regenerate those beta cells.
Yeah, that's like how the lab that's how these topics start. Mm-hmm. But then a lot of times what happens in research is then you start getting deeper into like the question of like, well, how does the pancreas, like it's developing like early in the organism, you know, what are the signals that in the pancreas, like, because half of it becomes the exocrine pancreas, which makes like digestive enzymes and bile and stuff. And the other half, less than half mass wise, but the other part becomes the endocrine pancreas. And then that splits up into, you know, some of the cells become alpha cells and make glucagon and beta cells. And they're pretty, you know, they differentiate and then they stay that way. So, and then if you kill a bunch of the beta cells, can you get some of the alpha cells or some of the delta cells to, you know, go become beta cells, or maybe undifferentiated like cells, like ductal cells, different kind of cells that aren't doing an endocrine job that are just there. Like, is that a population that you could target with some type of manipulation to send them down the cell fate to replace beta cells? So it's both like you want to get that end result, but then you also want to like understand the basic physiology of it. And like, why is it, you know, how does the body know, like, how do these cells know I'm supposed to become a beta cell? So yeah, that's
really interesting. Do you think it's largely from the electrical signaling that's happening, like the bioimpedance, what you would call it?
Voltage potential is what you call it. So yes. So the mainstream, like the current mainstream idea, which is, it's not incorrect as such. My position is that it's not incorrect as such, but basically that a lot of work has been done, whether it's in fish or all kinds of organisms, of doing RNA sequencing during embryonic development. So they'll like take all of the cells really, really early and see what genes are they expressing, get all the RNA and amplify it and read like what genes are getting turned way, way up during like 1 hour post-fertilization, 2 hours post-fertilization, you know. And then when you have real tissues, like what's going on in the skeletal muscle, what's going on in the bone in this part of the body, you know. And so this has been done, tons of work has been done. And so they're like, okay, at this point in this organism, you know, this as this tissue is differentiated into its different sections, some of them start making these, you know, expressing these genes a lot and not expressing these other ones. And then on the other side, you know, for the different cell fate, the different tissue fate, they're doing a different expression pattern that we can, you know, that we can see. And so the physiological theory and then the attempted application is to try to get cells to upregulate those genes that they are normally upregulating in the process of becoming the thing you want them to become. But the problem is it's kind of impossible to explain from just that mechanism how a cell could know where it is in like 3-dimensional space. So one of the big questions is this geolocation. And so one of the concepts of the bioelectricity paradigm is that across the body plan of every animal, there's differential. So the thing about bioelectricity is cells, especially some cells like nerve cells or muscle cells, can fire, so have an action potential, but then they also have a resting potential. So the action potential is when a cell's doing something, and that's kind of something else, but the resting potential, they'll say, oh, the resting potential is minus 50 millivolts or minus or whatever, but it's different for every tissue and it's different across the body. So it's like a wave of like slightly more, like from the core out and from the head to tail and stuff like that. There's these patterns. And so the idea is that seems like that would make sense as a way for it to geolocate, for these cells to know. And also, like if you implant a tumorous tissue, or if it's a tissue is spontaneously, like a cancer, it will not be in line with the proper. So if you use patch clamping or some type of dye for voltage potential, you can show like, hey, look, that tumor, it's in a place in the body, a pancreas tumor or a whatever, liver tumor, where all the cells around it, its tissue brethren are at minus 55 millivolts, and it's at minus 37 or something. It's out of sync.
That's really interesting.
So that's part of like it losing its control, and it just starts growing malignantly. So the bioelectricity idea is that what's telling the cells to, at 3 days post fertilization, or at what point in this development of this tissue, we're turning up this gene, we're turning down this gene, this one's at maintenance level, whatever, is mostly this kind of sense that it gets from its own resting potential, which affects all kinds of things like calcium and all kinds of things that just have normal accepted mechanisms of controlling gene expression. But yeah, sort of this, and knowing what's around it, knowing like where it's supposed to be, like how many of these, how much sodium and potassium am I supposed to be like kind of pushing in and out and having associated with these different proteins. So that's like kind of the two different schools of thought.
So I've got two questions based off that. What is like the range in these things? So it's like, is it going to be like a millivolt all for the liver versus the pancreas? Obviously there's a spectrum where like some are going to be further apart than others, but is it very, very precise? And the other question I thought of was that in terms of like transplantations, like are human to human, is this going to be, are you and I, your livers and I going to have the same voltage potential? Or is it going to have slightly variation there and they can use that to influence like the success of a transplant or something like that?
That second one's interesting. I don't know off the top of my head, like for each organism, I would say just based on looking at different dye images and patch clamps, like you might expect an organism to have something in the range of, say, at least 20 millivolts of difference from like its most to least polarized cells, perhaps maybe as much as like 50 or so. Mm-hmm. And then during certain situations like injury, like in the organisms that can regenerate, they have a lot of at the injury, like where it creates this new blastula that repairs the limb. It gets totally the difference is bigger than the natural difference across the body plan. The second question, I don't know. I've never even thought of that. That would be an interesting thing, like these unexplained, transplant rejections. And because, that's one of those areas of medical science where they're like, oh, well, we know the blood type thing, right? And there's like things that they're always finding like, well, you can't, it's better between family members. We're not exactly 100% sure why with this particular organ, but like the chances are X if it's a stranger and the chances are Y if it's a relative or whatever. But yeah, that would like, I would not be surprised. I would assume that everybody has a little bit of a signature there. What I would assume is probably pretty similar between humans is like if you're healthy, if you don't have some type of like tumorous situation, is the range like that you would have a similar difference between your highs and your lows, but maybe like starting a few millivolts this way or that way.
Yeah, there's something. Have you ever seen that repeat meme where it's like the peanut butter jelly and vitamin 3? He's like,
I don't think so.
I'll have to send this to you. It's one of those deep fake ones. It's like together peanut butter and jelly with the inclusion of vitamin 3 could kill the skincare industry entirely. And that's what you're talking about, like the white blood cells. I could just hear Ray Pete being like, it actually has to do nothing with the antigens on the blood cells. It has to do with the electricity. That meme popped in my head. I just thought it was funny. Would you recommend that? What was the book? It was
The Body Electric by Robert Becker.
You'd recommend that?
Yeah, it's like a popular. It's not like a technical book. It's written for normal people to read. It's like a narrative. It's basically it's like a kind of an autobiography about his research career.
Oh, interesting.
So yeah, it's very readable. Yeah, it's a good book.
What's his name? Kind of talks on he's become pretty popular. Becoming Super. Joe Dispenza. He talks a little bit about the bioelectricity and things like that. It was kind of at the time I was reading, it was kind of a little bit woo woo over my head at the time. So I would like to come back to it, but it was interesting to hear what he talks. He talks a lot about the chakras too, and ties those together.
Yeah, that's another thing about this whole world is that there's a certain vibe, like there's a certain type of person that will hear a phrase or a term and then latch onto it like it's like a magical incantation. Because I mean, from the scientific bioelectric perspective, it's totally reasonable that certain aspects of like traditional Chinese medicine are working with these things, but some people will kind of just start talking about it in a not a very rigorous way. And it's just unfortunate, but everything that's like not mainstream is always, and sometimes even things that are mainstream, but especially things that are fringe, they're always like a target for like weird people that just sort of pop up and be like, oh no, like it's it's this. Yeah,
I think and this is perfect transition in talking about like the evidence-based community, and like it's kind of, I feel like it's lost its merit in some aspects just because like, there's a lot of evidence the evidence-based community won't like accept or like utilize in theirs. So I think this is a perfect transition talking about some mice and rats. So you've done a lot of work on mice or rats as well?
Mice mostly.
Okay, cool. And your thesis was on feeding mice different diets, basically with different percentages of not fats, but just the type of fats, correct?
Mm-hmm.
And basically what you found I should have read the paper, I forgot to, was that the more PUFAs they ate, the more obesogenic, the fattier the mice became, correct? Or if you want to elaborate.
Yeah, all the fats actually. I was a little disappointed because even the coconut oil group got fatter than the lower fat group. And I think in the female mice, it was almost not different at all. But the main difference in the males and then the females was glucose metabolism. So the coconut oil groups, even though they were pretty close in fat gained to the other, the higher like PUFA, the higher omega-6, like vegetable oil fat groups, they had better glucose disposal from either glucose or insulin tolerance tests. And
that's largely, in your perspective, is like the PUFAs having a increased effect of blocking the Randle cycles, of blocking the ability to oxidize glucose?
Yeah. I mean, the problem is like, there's just like so many potential explanations. Like it could be that, different types of downstream products like prostaglandin stuff that's just being made and interfering somewhere in some tissue that's needed for glucose disposal. And that's being alleviated, even though there's a lot of body fat, which is generally associated with poor glucose disposal in the coconut oil groups. There's just something not happening because I don't know if they were quite as good as the lean, like lower fat groups, but they were like either as good or in between the higher omega-6 groups in terms of glucose disposal. So yeah, it could just be that the free fatty acids they have floating around are less competitive with glucose being used as a fuel and therefore taken up, in its excess during a glucose tolerance test. All kinds of things with like the insulin receptor and what types of chemicals block its action, insulin resistance. So yeah, I can't really say, and I don't even know how. You would almost have to just take the cells and do like an ex vivo experiment if you wanted to get like into Randle cycle questions.
Okay.
You could just do that in the whole mouse. Because there'd be no way to, you can't just like look like at the mouse and
That's
be
the
like,
Randall cycle. Yeah.
yeah, like, oh, I can see the carnitine palmitoyl transferase system is sluggish in that one.
So if you could maybe do further research on this. I know you don't want to do any more research, but what would you add to that experiment?
Well, the first thing, I mean, when I first finished, that's one of the frustrating things, especially when you're doing a PhD, is especially for me, because actually most people put in much less creative input into their projects, especially at that stage in the research career. I had pretty much total creative control. My advisor was in endocrinology. Mm-hmm. So I was in the nutrition department, but he was in the endocrine department. So he didn't even really know a lot of the things that I was trying to look at. So he just basically taught me like what he does in the lab. And then I just applied it to my nutritional question, which he had never done nutritional experiments before. And so that was really great that I had, it like forced me to have to do certain things that a lot of graduate students, like they just kind of get handed off like a certain thing and then add a little bit of creative input to it. But then I just was learning so fast about these different things as I was doing it. And with mouse experiments or any animal experiments, you have to get mice, you have to breed mice, create a colony. They have to be a certain age to start the experiment. You run the experiment for like 3 months. You analyze the tissues for another 6 months. And you can't just go like, oh, I forgot to like such and such. I'm just going to do it again. Cause then you lose a year. It's like a 5-year thing. I mean, wow. People get so time screwed in like graduate school and all this stuff. Like if their experiments don't work, they don't have publishable results, like they don't get the results they wanted, or like the opposite results, which is also kind of okay. Like they get sort of this crap in the middle. So you kind of have to just go with what you get. So in retrospect, instead of just having fed the mice these diets for, I think it was 3 months. So they were about 3 months old, and then fed them for 3 months, and then did a couple, insulin tolerance tests, glucose tolerance tests, looked at their body composition, and then killed them and harvested the different tissues for different assays. I would have liked to have taken staggered times, like, so, feeding them for at 1 month in, 2 months in, and looked at their tissues to see like how much of their tissue fatty acid composition is different, or to see, because the worst results I got was the qPCR results, the gene expression results for inflammatory genes in the brain, the hypothalamus, the arcuate nucleus of the hypothalamus, which is considered like the most important for appetite regulation, and a little bit in the liver and stuff. The results were all over the place. And I thought to myself afterwards, well, if there's some type of inflammatory process or something that would block insulin or leptin receptor or whatever genes that I might be targeting their expression, and to make these mice fat, it would be interesting to see if those processes were turned up like as they were getting fat. And then once they're, because who knows, like once they're fat, it's like maybe this gene's expression goes down or whatever, but that doesn't mean that it wasn't really high in this group versus this other group as they were getting fat or as they were getting glucose intolerant. So that was like the main thing that I thought of. But I mean, it's just like anything else. Like once you finish something, you go back and realize like you could just go on forever and change a million things.
I feel like people, including myself, don't appreciate how hard science is. It's like, it's so fragile, and like hearing your perspective, because it's so interesting hearing you talk about actually doing the research, foot in the ground. Like there's so many different ways you can interpret things. And I'd like to talk about like how, you could interpret the same results. Like I think I was listening to you talk on the strong sisters, and I'm going to give like a horrible example, but like you could look at mercury and say it's beneficial because it upregulates glutathione and metallothionein to detoxify the heavy metals. And it's like, oh, like what is this supplement? Like, because you look at sulforaphane, let's say, and it does the same thing. It's like, that's beneficial, but mercury has the same mechanism. So a lot of it's up to interpretation. And just FYI, I just made those things up off the top of my head. I have no idea if those are real. So don't quote me on that. But yeah, it's very interesting how much science is like interpretive in that aspect.
Yeah, that's kind of the part that I like about it. Some of the technical stuff, like it can get kind of like a Zen thing when you're like doing repetitive pipetting and stuff like that. And that can be cool, especially if you get to the point where you can like listen to music or like even an audiobook. Like that's kind of my favorite place to be, where I can just zone out and do something. That's nice. But yeah, what's really nice is like, I really am interested in, you look at the research and then you go, wait a second, like these people aren't even interpreting their own results. Like there's missing like a kind of logical thing. Like they did all these experiments. And that's kind of one of the issues, is that the techniques and there's machines being invented to measure new things with more precision all the time. The techniques are basically improving fairly continuously, probably hitting a sort of a plateau, but at least from when like I was a little kid till now. But the actual thinking is like, I mean, to be generous, I'd say it's stagnant, but it's probably a little reversed in quality. Basically people just have like, the main way that most scientists work is there's certain resources like machines, different assays they can do in their lab, and they just apply those techniques to some type of model system that's outlined in a grant that says, look, this is what we're doing. And they just kind of like, okay, well, we're going to mutate this gene, or we're going to like give this drug that targets this. And then it's like, well, what were the results? Okay, well, let's use the next drug that's like the next most similar, and just do all the same experiments. And they just kind of like apply, rather than having some type of, big philosophical thinking about it. Very few scientists do that. Like you see sometimes, like imagine like the TED Talk type thing where it's like, somebody has these big ideas. That's like maybe 1% of people in like biomedical research. Most people are more like worker bee-ish about it. A lot of people don't even like presenting the results because they don't want to be asked questions where they would maybe have to like say something other than just this was the result, but I like that stuff. And yeah, it's, it makes it interesting, but basically you actually kind of don't have to do that in science anymore for a lot of these fields. You just sort of like, especially if you have a really like sexy process that other labs can't do, you could just like generate papers because it's like, well, nobody else is doing this technique. Oh, it's such a cool technique.
So it's almost like you're generating data for other people to interpret at that point.
Yeah. Yeah. I mean, there's some big problems with data generation. But yeah, I mean, the meta-analysis culture is just going to continue to grow because the amount of data is always growing.
Yeah.
And the idea that you can compare, that you can just put two different studies from two different labs together as like one big, piece of data, and then do that like a dozen times and say that has like statistical power because each one of these has an N of 30. So now you have an N of 160, whatever. What's 12 times 30? 360.
Yeah.
Yeah, that's just, I don't know, that dog don't hunt for me, but, yeah, I guess it's hard. I don't know. There is that culture though, that Reddit, like I fucking love science culture, which kind of goes the other way, which is like kind of treating scientists as these like priests. But it's a very surface level. It's like, oh yeah, I love science. Science is so cool. Oh, but like they don't know anything about science. And I don't think they want to know. It's like they want it to be like, it's just a bunch of like Rick from Rick and Morty. Like it's just like that guy.
Yeah.
Doing cool stuff. And like, that's what science means to them.
That'd be cool though. I do love Rick and Morty. So yeah, it's interesting. Yeah, that's one of the cool things I really like about Ray. And I probably talk about him too much, but like just because he's interested me in philosophy and like learning about how to think about things in different ways and interpret things, as you said, he's enlightened my interest in things outside of like health and nutrition as well, like the importance of continuing to learn about that. But I find it really interesting. You say you really enjoy pipetting, because I was a bio major as well at Maryland, and I was the worst lab partner you could possibly imagine. Everyone else came in there like having hours of prep, and I would just show up with a group and be like, all right, like read the lab and figure it out as I went. usually went fine. But I was just like, dude, I hate this.
Yeah, I mean, when you first start using a certain tool, it does kind of suck because you have to think about it.
Mm-hmm.
But once you get past, it's just like driving. Once you get past that and you can go into autopilot, you can get in kind of like a chill meditative state.
I can see that. So in terms of the mice diets, I've heard you talk about how one of the constraints in terms of mice diet application to humans is the timeline. So like 3 months in a mice trial, which probably like 6 months after like their infancy, whatnot, is like 25% of their life, more or less, or something, like a solid percent, versus 3 months in humans is like nothing. What can we do? Like, how do you interpret that when you're looking at mice research, or just trying to be applied towards humans?
I think most people there's like probably a general time to time comparison. Like, yeah, 3 months for a mouse would be considered like, some years for a person. So it'd be considered, I guess, health relevant. Like, you can give a mouse diabetes or whatever, like something that might take, several years if somebody ate like a really bad diet and didn't exercise and stuff like that. But yeah, I mean, the comparisons start to break down. And this is another, like what I said about the different tools, like a certain animal model is a tool. So the original idea was, well, we can't just like grow people and like, you know what I mean? Like put them in a cage and like do these things to them and kill them when we want to test their tissues and stuff. So, scientists have figured out like, okay, well, look, mice and humans or dogs and humans, even frogs and humans have the same physiological effect to like this stimulus, this drug or whatever. So, okay, so we can use it. Like, let's say the same toxin affects this type of frog, like it damages its liver the same way it damages human liver, So, okay, so if we want to understand that and we want to block it with like maybe some other thing that we think might be protective or whatever the experiment, we could probably do that in a frog, maybe. So that's kind of the thinking. Mm-hmm. But then of course you can't just go obviously straight from that to like, okay, this will definitely work in a human for sure. But it's reasonable thinking. And, but then what happens is you get a lab that has, a colony of frogs they use, or a colony of mice, or in my case now zebrafish. And then instead of it being like the 1 degree of separation where it's like, we have this question, we can just, use humans for this. Mm-hmm. At least not for terminal experiments. And we have a reasonable, like some type of evidence, a decent reason to believe that the systems are similar in this type of animal as to humans. So we're going to ask the question in this model system and then go from there. But once you get that up and going, then it's like, well, we have all these animals, so let's just keep using them, keep asking questions. And then it kind of just becomes about like the biology of the mouse. So it's like, what makes a mouse fat? And you lose sight of like the whole idea. Yeah. And if you don't keep that in your head, you will just fall prey to that because every day you go into the lab, you weigh the mice or whatever, you give them a certain type of food, or maybe you give them a drug, and that's your thing. And then you start to learn about mouse physiology because you have to analyze the results. So you have to like, oh, okay, well, they're different in this way. So like, and then if you don't keep it in your head that like, this is all kind of like, I should always be thinking like of this as a model system, not as the thing I'm studying. Then you'll just start to like, then you're like a mouse biologist basically.
Yeah, that's a good point. It's very interesting. You brought up Rick and Morty, and I was thinking when you said we can't test on mice, like at least with lethality, I was thinking like, his battery pack that he like has the whole world of little, like we could just test on them in there. Like he made his whole universe and then they made a universe. That was kind of funny. But so in my experience, I would say, and I would like to hear your thoughts on this. Like biology, the rule of thumb is biology is conserved. So like, the end of the day, like you and the mice are the goal is to get oxidize energy through your metabolism, mitochondria, to support all these functions. And there are obviously like huge differences systemically between us and like a mice. And Chris Masterjohn just published a really interesting paper about coprophagy in rats, I think mice as well, how it's like we can't look at any of the microbiome results from rats or mice because they exhibit coprophagy where they eat their own poop and they seal the poop in a layer that allows it to go to their colon. So it's like it doesn't apply to humans. But generally, I think that's like more so an exception to the rule than the rule. Would you agree with that generally?
It really depends what you're talking about. I mean, it's totally that this is part of like this should be a big part of being a scientist, is the ability, the kind of cross biological knowledge of what's a reasonable question for this model system and this one. And yeah, so like if you're doing microbiome research and you don't know that it would affect the microbiome, like, cause I raise mice all the time, and yeah, they would eat their poop all the time. Like, it actually it makes things easier keeping the cages clean. And yeah, they're different in that way. And so, yes, there's very good reasons to believe that, if you were just looking at like fecal microbiota, like the pieces that you managed to collect, that would have a big effect. So maybe that's not a good model system for that. Mm-hmm. But yeah, the more general, I guess, the phenomenon, like if you wanted to study like cyanide poisoning or something, like that probably kills every mammal more or less the same way, you know? But then if you're getting into like testicular cancer, or like a certain type of testicular cancer that's resistant to this chemotherapy that works for most of them, but not this one, like the more specific you get, and the more, you can kind of imagine like what's more specific to a certain biology, like a certain type of cancer is probably more specific than the reaction to like a drug, or like how much Tylenol can you take until your liver starts to die? You know, that's like that's probably like, you could probably do that to a dog and a mouse in a similar way. So yeah, it's very case by case specific. And so on the one end of the spectrum, you have the people that just set up a lab and they have their model system and they just kind of unthinkingly apply that to everything because economically they kind of have to, because they invested in this thing and that's just how it is. Like, it's just how it works, unfortunately. And on the other end, you've got like the evidence-based people who are just like, well, you can't use animals for anything because like we're humans, dummy. It's like they don't even want to think about, they don't want to have to learn biology and think about maybe there is a model system because, certain diseases like cancer in humans, you could give somebody cancer really fast with certain chemicals or like radiation, but assuming like, let's say there's a process that maybe starts happening sometime in their adulthood and they don't have a measurable tumor for 20 or 30 years, or they have a measurable benign tumor that becomes malignant when they're 65 or something. Like they had a growth, they had a lump, every year it gets checked, it's fine. You know what I mean? So obviously there's something been happening for a long time, the time of many mouse lives, perhaps even a whole dog's life. So for a question like that, if you can sort of look at the system, like skin cancer or something, you're like, hey, is skin cancer kind of similar with rats and humans? I don't know. Maybe it is. Okay. Well, you could do a hell of a lot of research on what progresses this type of skin cancer, like assuming this organism gets a similar, like you can look at it, looks the same, has certain molecular signatures that are the same. You could look at like thousands of mice or rats and give them different types of drugs and different types of treatments to try to prevent the progression or reverse the cancer over the time of like one person, would take to maybe develop that cancer or not develop it. Not to mention, obviously, that you can't just be giving people cancer anyway. Yeah. So it's not even, but just practically, even if you could, it would take like lifetimes, like one scientist's lifetime could not even really ask some of these questions in a human. So then, the evidence-based people are like, well, okay, so we have to just use like epidemiology or these clinical studies that go for like 3 months. Like maybe, the cancer started to be slowed down. Like, they've been put on this drug and it or obviously most of the time it's with nutrition stuff. So it's like, oh, this group started to lose weight. But yeah, I mean, if you have a perspective where somebody's health is their entire life, then, a 3-week diet study or even a 3-month diet study is not very satisfying. I mean, if your goal is just to lose weight, then you could have like an intervention that would lose a significant amount of weight over that time period. This one works better than this one in these types of people. It's fine. It's great. But if you're asking questions like, how to maintain a healthy weight throughout your whole life, and healthy glucose metabolism and stuff like that, I mean, there's really no clinical study that can look into that. And epidemiology isn't, it's not like experimental, so.
And just for the listener out there, so when he's referring to epidemiological studies, you're basically referring to like associational studies over times, which are basically like, in large part, like surveys, right? Like you ate 30 donuts on average a month, and it turns out that you have a 5% increased likelihood of colorectal cancer. Some like it's just like statistical surveys on averages, correct?
Yeah. Just population-wide stuff like maybe hospital data. Like, hey, out of all of our heart disease patients of all like American hospitals, or 65% of American hospitals reporting all cardiovascular disease patients, X% took this drug, or never took this drug, or X% were vegetarians or not, or whatever, stuff like that.
How confident are you in that? Like, if you feed, let's say, mice over their lifespan, I don't know, you can give probably a more accurate percentage, but let's say 20% corn oil in their diets, that they will exhibit metabolic syndrome at some point in their life. And you can change my numbers around, but I'm just being kind of theoretically talking. Like, how confident are you in that?
I'm pretty confident in that. Although I'm pretty confident that anything over, even if it's like what I would consider better fats, like the kind of fats that would just be in like a normal meat or whatever. For mice, you probably don't want to go over like 30% of their calories. They'll probably get some type of issue. But yes, I would say faster with something like corn oil. And yeah, 20%, that's quite a bit for a mouse of their calories, considering they would have 0% normally. Yeah, I'd be like pretty confident. I mean, there's probably different types of drugs you could give them that like, target like the insulin system, and maybe if you had them like hyper exercising, so you kept them like artificially lean, or you'd had them do different types of things. But yeah, just a normal mouse in a cage, just like all the other ones in the university, where they have a wheel they can use or not, or sometimes they just have like a wooden block they can like chew and play with if they want to. They can play with each other or not. They can choose to be lazy. They have free access to food. You're not restricting it. So obviously if you gave them 20% of their calories from corn oil, but restricted their calories, you could keep them lean. It's just a question of, if they start to gain weight, you just restrict their calories.
That's a good point. Yeah.
But yeah, if they ad libitum access to food, not forced to exercise, not given anything, they probably develop glucose. I mean, that would be consistent with my personal lived experience of the research.
How could we extract that? Like, what do you think it would take the evidence-based community to say, like, okay, like this is a reasonable assertion to bring to humans? And again, you don't have to do like the 20%, but just like if we had, let's say we had data at 5% corn oil diet, that mice, that all the conditions you just listed, they can eat as much as they want, they can exercise and play as much as they want, but they get 5% of their corn oil diet. What do you think it would take for like the higher ups in the evidence-based community to say, yeah, I think seed oils are bad for us, or corn oil is bad for us, quote unquote?
Oh, I know exactly what it would take. It would take, a 3-month or a 6-month study of, 100 people fed this macronutrient diet, this percent, how much of the 3 macronutrients, and this one's high in corn oil. And then another group where it's not, it's they use olive oil instead, or coconut oil or whatever. And that the one that's high in corn oil has this problem, that problem, the other problem that's not seen in the other group. That's what they want, which is fine. I mean, it's reasonable. Like that, that's what I want. But it's just, the thing is, people are very variable in their ability to, handle different nutrients. Like, there are people that can last, like, I have people come to me and be like, oh, I was doing like 0 carb for like 5 years and then my health just like exploded. And there's people that have that story after 2 years. And I mean, think about that, 2 years, 5 years, these are already longer than basically any clinical nutritional study that I'm aware of. I mean, maybe the cost of doing a clinical study for multiple years is just insane. The resources, it would just be crazy. So that what I'm talking about, these like anecdotes, people come to me, many people, to the point where it's maybe even statistically significant, with the same story, after X number of years, those people wouldn't even show up in a clinical study. Like, if you put them on a 0 carb diet, they wouldn't have that outcome over the course of, so you could just say, well, hey, there's no evidence to base that, people's not eating carbs for somewhere between maybe 2 to 10 years has a very high outcome percentage of like, I don't know, like what people used to call like adrenal fatigue or whatever. These kinds of issues of deteriorating sleep and energy and just the whole thing, they lose a bunch of weight, then they kind of just slowly start to gain it back after like multiple years. You can hardly even tell. And their fasting glucose starts to just creep up. Like, it got better when they took out the carbs, and then it just all of a sudden now they're like bumping up into almost pre-diabetic fasting again. And it's like, well, I can't cut more carbs, right?
You can try.
It's like a negative carbs. Like, you could like bleed yourself, but like go back to medieval,
just take out,
bleed out the glucose.
Source. Yeah.
Yeah. That's the problem. So that's what they want. And so on humans, the relevant time scale, like if I was going to design some fantasy experiment, it would be, I don't know, 10 years or 20 years or something, at least 5 years of like free living people. A lot of them that are given like a pretty high, like a moderate fat, but like very high, vegetable oil, whatever kind, have to think about that a little bit, because, some of the vegetable oils have like more omega-3 and stuff. That was actually one of the difficult parts in designing my experimental diets, because I wanted everything to be the same. I basically wanted the fulcrum to be omega-6 versus, any saturated fat. So like, the 10, 12, 14, like whatever, 16 carbon, 20, like all of those, it's fine. So that was easy with the coconut oil, but with the vegetable oils, I had to like mix a lot of them. I worked with research diets, in which Chris Masterjohn used to talk about them a lot. They were right next door in North Brunswick from Rutgers.
Nice.
Cause it's like soybean oil actually has quite a bit more omega-3, I think, than safflower and like, so it's not as simple as just like, cause it's like, well, this one's like 2% omega-3 and this one's like 6% omega-3. So that's like a big difference. That could be, but there's like experiments where that's the experiment. Like there's, so your results, it would be hard to interpret. So you have to design it like that. But yeah, I would want to see, adult people, like people with normal health, normal weight, and see what it looks like for them to just be on this diet for like several years, maybe, ideally like something like 10 years. Look at like things in their arteries, like any kind of plaque deposition, like C-reactive proteins, just all that kind of stuff, Yeah.
And we're talking like billions of dollars at that point, I would imagine, for like your dream study.
I guess I'm not even sure that like just the practicality of following somebody and making sure that they stay on a diet for that long. I mean, it's like Truman Show kind of, because like they couldn't just, like if somebody was in this study, they couldn't just go eat a donut. They couldn't just go eat almost anything. I mean, depending how strict you made their thing, I mean, you could, if you wanted to give them more freedom, you would have to educate them very highly on what foods they can like cheat on. Mm-hmm. You know what I mean? Like they would almost have to be like a nutrition expert to know what they could eat to not totally mess up their ratios. of the fatty acids for this experiment. Like a normal person wouldn't know, like, oh, well, I'm allowed to eat like half of my calories per day. Like, you know, my diet is anywhere from 35 to 55% of my calories per day is fat or something like that. Like maybe you could have a range that wide and just have like one group that's really high saturated, one that's different. So they, you know, they wouldn't know that like, yeah, I just had a donut. Like I just had like 3 donuts. It's fine. Like it's a lot of fat, but I'm allowed to do that. But it's like, what were the donuts? You know, people don't understand things like that. So you'd almost, yeah, obviously you can't have somebody in a metabolic ward for
10 years,
a year. So it's even if you had like $1 billion, I'm not even sure it's like technically like feasible, because it would just, it's like, who's going to do that? Like who's going to be like on an experimental diet? It's hard enough to get people like the Framingham study to fill out a questionnaire every year for 15 years, 20 years. And they were like nurses, you know, they didn't have to do anything different. They just said like, oh yeah, I eat about 3 eggs a week. I eat 6 eggs a week, whatever. That's hard enough. You know, people you can see like over the years, people drop out, you know, like the end starts off at like 600 something. And then the end, it's like 200 something. Yeah, it's basically impossible. And the thing is like, so you just have to accept that and just be like, okay, there's just different types of science. It's all just tools, you know, like the pipetter is a tool. The qPCR machine is a tool. The scale is a tool. The organismal model system is a tool, and they can be used stupidly, and they are used stupidly. And just like everything else, it's like you have an example of something that's kind of dumb, and then you have a bunch of people that say, therefore, everything that is dumb and useless. And that's the evidence-based. That's like where they've gotten, is that, yeah, like some people overstate animal study results. Some people overstate even like in vitro stuff, you know, to be like, well, that means that you should be eating this type of antioxidant, not this one. Yeah, that's true. But the reactive or reflexive, like, therefore nothing of value could ever be gotten. It's just, I think it's kind of intellectually lazy, because they don't have to think about how these things could be applied. And it's just so easy to say everything except like this small piece of the scientific literature that's like extremely easy to interpret, because it's literally just like, we fed these people for 3 weeks on this diet, and they, you know, their muscle mass changed this much from resistance exercise, or this much. And like, you don't have, it's just like for dummies, you know?
Yeah.
I can't help but think that's part of it.
Yeah, no, you make good points. That, I mean, it has to be. We just physically, it's just impossible to do the science, the rigorous science that we'd like to do on as like your test subject, and even to do like the 3 to 6 month one, which you said was like what the evidence base, if that was possible, which I mean it might be, but it's again really hard, as you said. It's probably going to be hard to see outcomes in humans that are physiologically meaningful, we'll say. And do you think that, like, you know, your friend let's make a friend that goes vegan and after 10 years is fine, versus someone that goes a year and is like B12 deficient? Do you think a lot of that is genetic? Like, I'm sure you've looked into this, like it's got to be bouncing around your mind. Because Ray tends to say, like, I've like very rarely heard Ray talk about genetics, except saying that he's like, the genetics is crap.
Right.
So like, it's always has been bouncing around my head, because you go to school and it's like genetics is everything. So what do you think on that?
Again, I think that would be like a case by case. I don't know that much about genetic differences in B12. One thing that I know a little bit about is vitamin A metabolism. Specifically, there's animals, and I think between people, they have vastly different expressions of the enzyme. I think it's like CPMO1 and 2. They cleave beta carotene into either 1 or 2 pieces of retinol. So if you like have high function of that enzyme, then you could like not eat a lot of animal preformed vitamin A and get by really well for a long time. And if you don't have a lot of that, then, you know, you wouldn't get by so well. And then there's also storage capacity differences. I don't really know much about that. But yeah, I would assume that depending on the nutrient, it could be anything from, you know, a very small % genetic and mostly just whatever you were doing before you made the change, to like mostly genetic.
It's interesting to consider because it's like these unasked questions. It's a lot of people. There's a lot of commonalities, right? That you see like the Saladino and I guess Liver King as well, all going from like hardcore carnivore keto to animal based. And you've talked about this as well. I'd like them to give a little bit more credit to Ray than they do, but like there are these like it's kind of like a time bomb for a lot of people, right? Like it's a lot of like these optimal diets become, which they felt great on, kind of start to not kill them, but like, you know, they feel worse than they did when they at least had their pinnacle experience.
I mean, like everybody's gone through it. It's like I was saying, you know, I get contacted by all these people. I didn't really have a health crash, but you know, I had certain things that I noticed. And I'm sure if I had stayed, you know, kept trying to just, you know, oh, carbs are toxic, you know, kept with that mentality, I probably would have had, you know, more issues. And yeah, I mean, they just, those types of people, they can't, their brand is dependent on like being an expert. So they can't sort of give other people too much credit. They kind of have to act like they discovered this idea, this person's idea also. And like, nobody's talking about this, but actually it's like, even though a year ago, Paul Saladino was saying like, those people are wrong or what, you know what I mean? Like, so he was aware of it and disagreed with it. And then it acts like he just found it. Like, oh, I just found this thing. Like, and I'm going to present it to you, my audience. I'm so generous.
To be fair, I do think
that stuff.
Dave Asprey invented the stick of butter, the whole stick of butter in a coffee. That's just pure genius right there.
Yeah, he did. He can have credit for that. That's fine.
We'll give him credit for that one. I heard you talking about how the Eskimo, have a genetic capacity or a genetic capability. They have an increased, when they go low carb, they have a tendency to do more gluconeogenesis versus going to ketosis, which I thought was really interesting. And then I have two questions based off that. How much of like, you know, in terms of even like the repeat diet, blah, 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 like, do you think genetics are going to influence certain things like nutrient requirements and like maybe like some people do well with like 70% carbs, like mice, or if some people do well with like closer to like 45, 30, how much of an influence do you think genetics has in like your perfect diet?
I think in terms like that kind of stuff, like the macronutrient ratio, I think it'd be pretty big. I have tried doing a super low fat diet a few times. And it's not like I get sick or anything. I just feel really weird. Maybe if I didn't have anything to do, like I didn't have to go to work and I didn't, you know, I could like push through and maybe see what would happen. But it's one of those things where it's just like, all right, I have to, like, I'm not, you know, back like in college when I was like doing these insane, like raw vegan experiments, like you can kind of get by with like doing crazy things. Like I just can't, that's just not how my life is anymore. But yeah, I mean, when I used to be on the Ray Peat forum, there's people that just swear by like 80% starch diet. You know, they're just like eating potatoes and rice, and then they eat like, I don't know, liver or something for protein, or like the Ray Peat proteins, like shellfish and whatnot. I don't know if I could do that. Like I feel like pretty designed to have a fairly balanced macronutrient mix. Like I start to feel weird if I don't eat any fat. And of course, you know, if I don't eat carbs, everybody kind of gets the same like feeling from that, you know? But yeah, I think some people can last a lot longer. And then protein requirements, I'd say they're probably more similar between people in terms of like protein synthesis. I think the biggest genetic differences are like how much gluconeogenesis, how much, you know, energy you can get out of proteins without, you know, negative effects and things like that. People probably have pretty different like urea systems and some of those systems because of like, you know, historically like very different amounts of protein in diets. So yeah, the way that I would think about that is to like engineer it, like look at what like very long trend diets are in different parts of the world and see what the big differences are. So like, is it, you know, between like somebody from like China versus somebody from like England? Like what would be the big difference if you could compare like for the past 1,000 years or something, like a relevant time period? It's like probably protein amount, you know, starch, certain, you just look, the person from England is probably like more animal foods, land animal foods. Maybe the person from China, like if they're coastal, you know, stuff like that. So I would assume that the things that actually were different in historical diets and different people's like genetic backgrounds would be the things that would be the most different for us now to consider. Whereas the things that are more similar, you know, I would just not look at first.
I would also add on to that, like the epigenetics, like, you know, your ancestors might not be very muscular, but you decided, you know, you want to put on 10 pounds of muscle. So that's going to change your genetic requirements for certain things. And just because you want to get yoked and go to the beach and look good, that sort of thing. And like your exercise requirements too, like, you know, going to jiu-jitsu might, you know, most of our ancestors were not doing jiu-jitsu, things like that, where they might defer from sitting in a lab all day, all those kind of things as well. And then so on the gluconeogenesis question, how much of gluconeogenesis is going to come from protein versus glycerol? Do you have any idea? Because I've looked into this and I haven't read much of the papers, but I do know it can come from the glycerol molecule. And people are always like, "Oh, gluconeogenesis is from fat and protein." I'm just like, that's an interesting point. I don't have a good answer to.
I don't know. I would assume that in a normal state that most of the glycerol, like if a fat is broken down, is probably sent. Like, can you take glycerol and just send it right into a triose? You know what I mean? Like skip the like not have to make it. Probably has to get made into glucose to get out of that cell that it was broken down in. Okay. But I think it could be broken down as straight energy, like as a triose. I haven't really like looked at all those flow charts, you know, of like the different enzymes because sometimes it's like you just can't get there from here. Like we don't have an enzyme to like get, you know, go from like when you get down to like 2 carbons, it's like you can't, like it's very like the only certain tissues can take you back up to 3 and then to 6, you know. So yeah, I don't know. I think most of the glycerol goes into energy use.
Okay.
And but in the state of when energy is being, but if there's a lot of nutrients coming in, like fatty acids, then I guess it would just be like re-esterified. I don't know. It would depend on that kind of stuff.
What do you think about the arguments? And I'll have one more question after this, but the arguments of the keto diet being, it's mostly a guy named Menno Henselman. I don't know if you read his stuff. He's a big proponent of the keto and low carb. And he has a number of things arguing that keto, I think he believes keto is optimal for muscle growth, or at the minimum that it is just as good as any regular diet. Where do you stand on that?
I just feel like that is a ridiculous statement, because one of the biggest and I would say most reliable, you can't really call it rigorous, but like population-wide data sets not generated by a scientific researcher, is the bodybuilding community. There are a lot of people that are very open about what they're doing on bodybuilding forums. People are sharing their diets, even their steroid regimes, all the time online. And obviously some people are lying, but it is just such a long running truism about, muscle growth, performance, and like carbohydrate, the protein sparing effects of carbohydrate. And then of course in the research too, I think it's pretty well established. So, people come with their like novelty ideas, novelty takes about, oh, well, actually it's only because of this like one simple trick or something that like keto isn't quite as effective. If you do this and then it's just as effective or even more effective. It's just, I almost feel like that's something I probably wouldn't even look into, because it's like, I think we know at this point that muscles like glucose. I mean, they like to use it. And, when you're dealing with a whole organismal system, like it would be pretty weird for an organism to have a preferred fuel for like muscle firing, which is clearly like glucose because of the fast action of the power. And that's not related to what the muscle would prefer for like its maintenance and growth. It's like, oh yeah, we'd love to use this type of fuel. It's the best type of fuel. But actually we don't want that around to grow. To grow, in order to fire more, we don't want the preferred fuel that we use for working. It's like, just on that level, it's like really wacky. Although I have to say, I've never been presented with that particular guy's stuff. So I guess it's within the realm of possibility that he's just blow my mind.
I think he would consider himself evidence-based, and he's a really smart guy, but I think that a lot of the studies on bodybuilding, which is probably, as you said, like there's such a great data set because they don't have a lot of research. They kind of just figure out what works, is generally done on lay people. So when you compare 3 months on like a program where people are starting to resistance train versus like very trained individuals, you could probably see a similar muscle growth in the ketotic versus the carbs group, just because they don't have a lot of muscle mass. They don't have a lot to maintain at that point as well, which would kind of like be confounding. But yeah, I think what you said also makes sense.
Yeah. I would agree. That makes perfect sense to me. That like a untrained or like a resistance training naive study, or maybe like older people that are trying to preserve muscle mass and they don't have much. Like, you can do a lot. Yeah, it's really like, when we're talking about muscle mass, we're talking about like somebody who at least already has at least an athletic kind of, like if you're just like a skinny person and you've never lifted a weight, like, yeah.
Yeah, I like the bodybuilding world gets into a lot of arguments. It's pretty funny. I don't know, have you ever looked at Kassem's work?
No.
I would highly recommend. I've taken his certification. He basically has like, he's mapped out the whole anatomy of the body, which obviously is very mapped out, but he just takes exercises and applies them to them. So if like JPG, he's kind of popular on TikTok. Like he just kind of has done a lot of these like isolated, like lower lat exercises. And basically the idea that I used to be really like, the reason I got into nutrition was through bodybuilding. And so like basically the idea is that if you stretch a muscle and put it in a position where it's under greatest stretch, but has the greatest leverage to pull said load, that it will experience the greatest hypertrophy. And that's kind of what Kassem's theses is predicated upon. And there's obviously not a lot of research to do like on like, the effects of a lower lat pull around, where it's like very specific exercise and you have to set it up properly. But I'm just like, my opinion from a lot of like reading the work in nutrition race stuff is like, this just makes sense to me that this would work in the way. The body's such a smart, self-organizing system that like, why would it not take the route of the path of least resistance to allow the muscle that's in the best position to do the work? But people like to debate on that stuff and the nuance of bodybuilding. And I'm just like, I think it's a bigger rocks to focus on.
Yeah. At least in my point for lifting weights and stuff, I actually almost don't care about effectiveness because I'm not trying to really gain muscle mass. So it's like, it's really not on my radar. Like, oh my God, I should make sure my elbows don't cross 45 when I'm doing lat pull downs, or else I'm going to activate biceps. It's like, yeah. I actually do. The one thing I do try to do for most lifts is get, like the kind of mind muscle connection. And I do consciously actually, cause I have watched some of the, what is it?
JPG.
The JPG.
Yeah.
I have watched some of that, and I do think about that while I'm lifting sometimes. I think I'm like pretty good at isolating the lats from the arms. I suck at my chest. It's just the worst. Like I don't like, I can't really like bench anymore, and I don't even really want to. I feel like it's not that good for your shoulders, but I had like a pec tear from jujitsu, and it's repaired, but like I could probably never bench a lot again. And I never really benched that much anyway. Like the most I ever got, I was like, I didn't weigh a lot though. I think when I was like 155 pounds and I was coming back up after I did like added raw meat back in after the raw vegan thing, I think I got maybe like 225 for like 3 reps, which I was pretty proud of at that body weight. But I've literally never benched more than 2 plates for like a few reps. And I don't even bench anymore.
Yeah.
But like, even like I'll do like dumbbell stuff, and it's like so hard to feel that muscle and like to try to get that like, I just feel like it's so much more difficult than lats.
Well, a lot of that's because like you go to flex your bicep, right? You feel it a lot more on the shortened position because the contractile tissues, the sarcomere is so much closer. So like generally, and that's a lot of what Cassim talks about, like you don't feel the pec because you're in the lengthened position, but like you ever do like the chest fly machine.
Yeah.
So that's like why you feel it. Yeah. So like, but I'll send you some stuff. There's like the press around, basically like a lot of where you kind of use a cable and you kind of come around. That's actually like, I help a lot of people, and it's basically, that's what a Cassim stuff is. It's like you feel it more. Doesn't necessarily mean, I think, like not feeling it. So like a lot of people like don't grow their lats because they're doing lat rows, and that overloads the shortened position where it's like your lats are weakest and they're stronger up in this like tight position where you don't feel it as much. I think that's kind of a consequence. I think a lot of people just try to, and like that's the same thing for you, like with benching. It's like some people, you see like a lot of the pro bodybuilders, like, yeah, I grow huge pecs from benching, and some people are all delts. Like some people just fits really well. We're trying to fit sometimes we're trying to fit a square block in a round hole kind of thing. So it's like some people are just like built for benching. They throw up 325 after a week, and some people just suck at it like me. And I guess you were pretty good at it at one point, but just not built for the barbell.
No. No, I had a friend that was like doing a benching competition. We were like the same weight, same age. We lifted together. I was like as strong as him in every lift. My legs were stronger. Like I was a little bit taller than him, but he had really his arms were like as long as mine, maybe even longer. And he was like 2 or 3 inches shorter. So that's not good for benching, but his chest, like it just developed into like this Arnold style round pecs. He had like the most beautiful torso. Like he had this like 6-pack under these like massive pecs. And and for me, it was all shoulders. Like my shoulders were so much bigger than his, and you could just see it right there. Like obviously at the time we were only like 17. We didn't know this stuff, but like you could have just pointed to both of us and been like shoulder dominant, chest dominant,
Yeah. It's so interesting. I think it's a cool area, and you're a couple years older than me, but it's like there used to be, do you ever follow Athlete X?
Yeah, a little bit.
Yeah, like there used to be like such little information out there. So like he was like the only person talking about certain things, right? Like Greg O'Gallagher was a huge one for me. And like same thing with nutrition. I was less into the sphere, but like now it's like you can just like everything is so accessible because of the internet. Even like people like Biolane and all that stuff, like don't always agree with them, but like there's so many different perspectives. You can go down so many rabbit holes, which is one of the really cool things about the internet.
And one of the challenges.
For sure. Okay, last question. And we can just summarize this up because it's a very long-winded question, but why you don't want to be a fat burner? And obviously this is like predicated on the fact that like generally everyone is burning some portion of sugar, some protein a little bit through gluconeogenesis, and some fat. We're talking about the extremes where it's, the 90% starches versus like you can only have like half a chicken wing or else you get taken out of ketosis because of too much protein.
Right. Yeah, it is important to define the state, because I think I go into that in that old talk and stuff. But because you're always burning all the macronutrients. You're always burning protein, even if you have totally sufficient carbs. You're still doing some gluconeogenesis, actually, kind of a decent amount, because you can never kind of deliver the exact amino acids all the tissues need for protein synthesis all the time, and so they'll just kind of end up getting shuttled into different stages of like, they could get made into nucleotides, depending on like which amino acid they're, like different stages of breaking down and stuff, and mostly thrown into TCA cycle. But yeah, it's that switch that everybody's kind of familiar with. If they've done a low carb diet, you can feel it, or obviously, it doesn't have to be ketosis, but that's a very good indication that you have, gone to the other side, you're now a fat burner. You high free fatty acids in your blood, which is generally associated with either, very low carb diet, fasting, or diabetes. The
holy,
and then of course, and then with the diabetes, of course, with the added also glucose in the blood. So you got both. The other two, you have low glucose in the blood and high free fatty acids. So and then also low triglycerides, I guess, between meals. Your triglycerides would go up, obviously, if you're eating fat. So generally speaking, the most of the body, all the tissues are different, but so So it's like, you're mostly using fat in the flexible tissues, things like liver, muscle, and I can't even remember all the different organs, and they all have like slightly different uptake and usage of glucose and stuff, like to preserve. Like, for example, red blood cells, they can pretty much only use glucose, and brain tissue is kind of locked at about 50%. So the other tissues will just ratchet down their use to, because you got to have the red blood cells, and you got to have the brain going. So you're always using both, no matter what, anyway. But yeah, that state where you have just a lot of free fatty acids in the blood, you could also describe it with the Randall cycle situation, although there's really no test you could give yourself for that. But then when people hear the term fat burner, what they really are thinking in their mind is like, I have some body fat that I want to lose, so I want to burn it. So I want to be in a fat burning state. And they're kind of mixing up those two things as if just because you're using fat for fuel, that means you will become a leaner person. That's not necessarily true. Obviously, if you just go like kind of evidence-based, the more like calories in, calories out approach, that's one simple way to just oppose that thinking that, if you just, maybe in a day you burned 2,600 calories of fat, what if you eat 2,600 calories of fat that day? What happens, right? But then outside of that, just regular equation, there are, as I said, the fat burning state, the high free fatty acid state, is generally associated with, in addition to a very low carb diet, things that would be considered like not good states, like a diabetic state or a starvation state. And there are a lot of hormonal changes and physiological changes, generally a slowing of the metabolism, and then, turning up like the stress hormones, the cortisols and whatnot in those states, because when you're starving, your body does not, it goes, oh, okay, so use less energy, right? Like this is sort of an emergency situation. And that's basically the hormonal profile that you get when you are eating no carbs. So just on that level, it just seems weird that somebody would think that's good. Like there's been so many different ways to try to get around it. Like, well, cortisol's good in this situation, but not in this situation. Or the most brave person and the person I admire the most is Amber O'Hearn. Mm-hmm. I met her actually in person at one of the ancestral health symposiums I gave a talk at. And she is forwarding her own like kind of paleo carnivore theories about bone marrow and like the way the human hand is breaking bones with rocks. And like, that's how we blah, blah, blah. But she's brave enough to just say cortisol is good. Like she doesn't run away from it and say, well, no, your cortisol doesn't have to go up. Like, oh, look at these people. They're eating low carb, but their cortisol, it's spiked and then it's chronically not that elevated above, blah, 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 blah. Like she just says, no, it's fine. It's good. Like, that's fine. But yeah, so basically to be a fat burner, in the way that we're talking about, where you're switching your body to using fat in the tissues that it can switch to the extent that it can, is associated with just what's generally mainstream considered like a stressful body response based on like hormones and its general metabolism, thyroid production would be hit, things like that. I actually asked Ben Greenfield that at I think the 2013 Ancestral Health Symposium. He was doing like a personal experiment with a low carb thing, and he was like drinking all these MCT oil things and stuff like that. And afterwards, after the Q&A, I was like, hey, like what's up with your hormones? Like what about your testosterone? And he was like, oh, that's okay. And I was asking him, I was trying to get to see if anything was getting messed up. And I finally got to thyroid, and he was like, yeah, thyroid's taking a little bit of a hit.
That's funny. That guy is interesting character.
Wacky.
But so yeah, I think that brings up a good point, or as you were alluding to before, how people like misconstrue certain things. Like starvation mode is like a real thing. Like not in the way like people construe it, but it's like there's a spectrum where your body tries to decrease its energy consumption. So you have, your so you can go longer between your next meal. It's definitely like a spectrum more so than like a switch people allude to. It's like you don't eat for 20 minutes and you switch on starvation mode or something like that.
Because people say I'm starving, like in between meals, like, oh, I'm starving. My stomach's eating itself.
Crazy stuff of that. Which, is just not true, but it's interesting. And then I wanted to ask you one other thing. I honestly can't remember, but
about the fat burning, or
yes. So when we're talking about the gluconeogenesis, do you think Georgia talked about the BCAAs and things like that? Do you think some of the now they're like, if they were like everyone's like, oh, they're good for building muscle and being anabolic. Now everyone's like, oh, they're anti-catabolic. Do you think the BCAAs are just helping to maybe not downregulate gluconeogenesis, but supply fuel to gluconeogenesis so it doesn't have to pull from your muscle stores as much?
I never really followed the branch chain. Like I remember hearing in bro science that was like a meme, like, oh yeah, you want your BCAAs. Mm-hmm. And then I remember at some point everybody just went, remember when everybody was about BCAAs? And I was like, I don't know. And then it became about essential amino acids. Everybody flipped.
Which I think is the dumbest argument, because the EAAs are, it's like, just eat protein, dude. Like, oh, it's all about the EAAs. I'm like, that is literally just protein. But
yeah, that sounds plausible to me. Mm-hmm. If you're, because that's basically the protein sparing effect of carbs, is that you're just throwing, the glucose equivalent substrate into a system that otherwise would increase its use of amino acids to feed into that system. So if there's certain amino acids that you have more of that lend themselves to that faster, then that makes sense to me.
Well, awesome. I highly recommend everyone go and check out that. That's from a speech that you gave, I forget what the actual article is called, but why you don't want to be a fat burner.
Yeah, I think it's, I had it here because I hadn't read it for like a long time. The dangers of fat metabolism and PUFA, why you don't want to be and in quotes, fat burner, because I'm referencing the colloquial as well as the like scientific state of that term.
We'll definitely link that in the show notes. It's a really good article. I really recommend everyone go and read that. And then where can everyone find you?
My YouTube channel is Nutrichronology. So it's like nutrition and endocrinology put together. So NUTRICRINOLOGY, Nutrichronology. Yeah. And my Instagram, I post some stuff on there. It's, what's my Instagram? I think it's like my name, but also the Genius Bits, all Genius one word.
Bits. There you go. Yeah. It's I like your account. It's fun. And I also like your Kyle and friends. You're doing some good stuff. It's awesome listening to you guys. And the podcast with Georgie or Danny as well. It was fun.
Yeah, I think Danny and Leo and I are going to do a fight companion for the UFC this Saturday.
Nice.
We probably would have been doing more of those, but now that I'm on Central European time, I would have to be up at like 4 a.m. To do that. But when the fights are in London, then it can work out for both of us.
Is Danny big into UFC as well?
Yeah, he's obsessed with it.
Really?
Seriously, he told me this is years ago. He's been like a UFC super fan for like at least 3 years, maybe even 4 or 5. When he moved to Mexico, I guess he moved in a place where it was kind of rural, he's been to maybe a couple different locations, but it was kind of isolated. There wasn't a lot to do. And maybe there weren't streaming services there. He just said that it's like he started watching MMA because I guess he could find it online. And he's just like, he's fully obsessed with it.
That's really funny.
And Leo used to train too. So, cause he's in LA. So he used to train, like he's got pictures with, what is it? Which is the one, not Hoyler. What's the Gracie that Henzo?
Henzo. Okay.
Yeah, I think he's got a picture. He sent me a picture with Henzo because he was like, check this out. Because we were like comparing notes when we first met. It's like, what? Because he has one of those long backgrounds too. You know, he used to do all the fasting and the different diets and stuff. And he would do the fasted, like super cardio and he was training jujitsu and different stuff.
I think he mentioned he actually worked with Charles Poliquin, who was like Kassem's mentor, who I was brought up before.
Yeah. He's big into that guy's idea. I use a lot of that stuff like for my lifting because I'm like sort of where I'm at now. I'm like almost 40, so I'm sort of transitioning into like almost like rehab style. Like I just want to
feel good.
Like I just could not care less about. Like I sort of care about some lift numbers. Like I have like certain fun goals I'd like to reach, but none of them are 1 rep maximums. Yeah. Like I don't give a shit about that. And I don't have a lifting partner, so I can't even do 1 rep maximums for like squats and stuff anyway. Like I'm not going to drop, 300 pounds or whatever the hell, like on the floor I'm working out at like a college gym here.
Yeah.
It's like an asshole.
That checks out. I did not know you were almost 40. Look, I would have thought you were like most like young 30s to late 20s.
Thank you. Yeah, I'm 38. So trying to keep it together.
Thank you guys all for watching. I hope you guys enjoyed this. Make sure to tune into our episode next week.